Now this question is related to a standing wave. So this says there are three waves and it is represented by these are the basically transverse wave. So let us write the problem. This is related to wave. This problem is related to wave. So if you see this says there is a wave Z1. This is a cos kx minus omega t. So there is a wave cos kx minus omega t. There is another wave Z2 and this is given as a cos kx plus omega t. Now you see the third wave we have Z3. This says a cos k by minus omega t. Now the question asks, the first part asks this: identify the combination of waves. So there are three waves and we have to identify the combinations of wave which will produce a standing wave. So will produce a standing wave. So let us say you have to find which two waves Z1, Z2, Z3 will be combining and it will resulting a standing wave. So what is the condition for a standing wave? If you see, a standing wave will be produced only if two waves must have equal amplitudes. So what are the condition? So they must have equal amplitude. So amplitude should be equal. So amplitude should be equal. Then what is the other point? Another is frequency of traveling wave should be equal and they should be they are moving in opposite direction. So frequency has to be also equal. So frequency should be same, amplitude should be same, frequency should be same, and third point, they should move in opposite direction. So one is moving along the positive x direction and another should move along the negative x direction. So if the three condition is satisfied, then only we can combine and then we can generate. So if you see the first one, kx minus omega t, so basically this is moving along the positive x direction. How? So you see the phase is given by kx minus omega t, phase remains constant always. So d phi by dt, that is a phase is not changing with the time in wave, we know. So d phi by dt equals to 0. So k and dx by dt is nothing but v minus omega, and this is equals to 0. So v is equals to omega by k. Omega is a positive number, k is a positive number. So this shows this wave is moving along positive x direction. Similarly, wave z2, so this is about z1. Similarly, I can say for z2, that is v, you can prove yourself, minus omega by k. So this is moving along the negative x direction. So now you can clearly see if I combine z1 and z2. So you see we can combine z1, this is the wave, and z2, this is the wave. If we combine these two waves, we will get a standing wave. So let us say if I combine z1 plus z2, this will become a cos kx minus omega t. Sometimes people write omega t minus kx. It is the annotation depending upon the book what they are writing. So kx plus omega t, because cos of theta is equals to cos of minus theta. So either you can write kx minus omega t or you can write omega t minus kx. So now you see if I take a common and if I apply cos a plus cos b, so it becomes 2 cos, so cos a plus b, 2 cos a plus b by 2, so kx plus kx, 2kx, so this is kx, cos a plus b into cos a minus b. As I remember, cos a plus b by 2 and cos a minus b by 2. So this should be omega t minus cos a minus b. I think this a minus b or b minus a. In case of cos, if this is it does not matter because cos of minus theta is cos, so omega t minus omega t, so minus 2 omega t by omega t. So this is omega t because cos of minus theta is, so this I can write 2a cos kx omega t Now see, this is the amplitude. So this is the amplitude for the wave. This is also question also asks, find the points where the resultant intensity is always 0. So this question also asks in the same part, what are the points, what are the x coordinate where resultant is 0, resultant intensity is 0, and we know intensity is proportional to amplitude whole square. So this means intensity is 2a cos kx raised to the power 2. So now I can write intensity is 4a square cos square kx. This has to be 0, so this means cos square kx is 0. So this is possible when this is pi by 2, so x kx is pi by 2, or it can be 3 pi by 2, or it can be 5 pi by 2. So from here I can write, so x are the pi by 2k, 3 pi by 2k, similarly 5 pi by 2k. So these are the points where the x will be 0. Now the next part of the questions, this is slightly tricky one. It asks, write down the equation of a wave that is, so if we have to combine, so there are three waves, z1, z2 and z3. We have to combine these three waves. What are the two waves I have to take? In the first case we are getting a standing wave. In the next case it says, what are the two waves that should be combined and that will result a wave that is moving along the positive x, moving along the direction that makes 45 degree with the positive x-axis. So I am needing a wave that is moving along this direction. So this angle is 45 degrees. So we have to write. Now you see, wave z1, this is moving along the positive x direction, and this is the wave that is moving along the positive y direction. So z1 is basically moving along the positive x direction, and z3 is moving along the positive y direction. And now see, the two waves are basically having equal amplitude, equal velocities, and because k is equal, omega is equal, so equal velocity, equal amplitude, and they also having equal frequency. So this means if I combine z1 and z3, we will get a wave that will be making 45 degree with the x-axis, because x1, this velocity and this velocity both are equal. Amplitude in this direction and amplitude in this direction are equal. So if I combine this and these two waves, so z1 and z3, so if I combine z1 and z3, I will get a wave, let us say z, resultant wave, that will making angle 45 degree, because this amplitude is same with this amplitude. So let us apply z1 plus z3. This will become a cos kx minus omega t plus a cos ky minus omega t. Now if I take a common, so cos a plus b, so 2 cos a plus b by 2, so this becomes k x plus y by 2, so cos a plus b by 2 into cos a minus b by 2, so this becomes 2a minus b, so this is a plus b. So basically we will have a plus b, I will have a omega t also here. So in this case, let us write again, so 2a cos a plus b, so k x plus y divided by 2, as well as we will have a term x plus y divided by 2, so minus omega t, will also have minus omega t. So cos a plus b by 2, and then I will have cos a minus b by 2, so this is omega t minus omega t gets cancels out, so k x minus y by 2. So if I take the constant term, we will have 2a. So let us say, are you able to see or not? Okay, so let us make something better. So 2a cos kx minus y by 2 and cos kx plus y by 2 minus omega t. So this is the another. So this is the resultant. So you see, amplitude depends upon x and y. So for different x and different y, amplitude are different. Now this amplitude, so this says what are the points where you will have zero intensity for all time. So this means I can always choose this coordinate. So this means the intensity has not to depend upon this coordinate. It has to depend only on this, because this is independent from time. So this function should disappear. So for my purpose, intensity should be proportional to a square of this term. So intensity, I can write, is proportional to 2a cos k x minus y, and this is divided by 2. Now this is whole square. So this is intensity. Now I have to put intensity is equals to 0 for minima, or you can say resultant intensity is 0. So cos of k x minus y by 2 whole square equals to 0. So what is my condition? So my condition is something like this. So let us put this condition somewhere here. So now I can write, so condition is cos of, so you see the back you will get the answer, cos square kx minus y divided by 2 is equals to 0. This means this has to be this term has to be x minus y by 2 is pi by 2, or you can have a 3 pi by 2, or you can have a 5 pi by 2. Similarly you can go, so x minus y I will get, if I multiply by 2, so I will get pi by k, or 3 pi by k, or 5 pi by k, or 7 pi by k. So similarly I will get this term. So now you see, if I put k is equals to 2 pi by lambda, I will get something better answer. X minus y is equals to pi by 2 pi by lambda. So this becomes lambda by 2. So I can say lambda by 2, and then it will become the second term 3 pi by k, and k is 2 pi by lambda. So this becomes 3 lambda by 2. So you will have next is equals to 3 lambda by 2. Similarly you can find next term will be 5 lambda by 2. So similarly these are the points where the resultant intensity will be 0. So this is an important problem. You see, you have to find out among these three waves which will result in the standing wave. So we have learned a standing wave is generated only if you have waves that have equal amplitude, equal velocity, equal frequency, and they are moving in the same direction. Now the second point we have learned, that is, if I combine these two waves, I can get a wave. So if I have a wave in x direction, we have a wave in y direction. Now we can get a wave along the diagonal, or say angle, make a line that makes 45 degrees with the positive x-axis or with the positive y-axis. Okay, so let's get the next problem.